This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
Linear governance frameworks, regulations, committees, reaction protocols operate at a finite speed, but when subjected to the explosive, uncontainable growth of exponential digital systems, these linear barriers are entirely shattered. This creates a structural deficit known as the infinity gap. Digital capabilities, from high-frequency trading algorithms to recursive machine learning, grow infinitely, while human oversight remains static. This chart shows the exact mathematical certainty of this divergence. A flat linear line represents human law, while the violently divergent red curve represents digital growth, defined by the limit of S sub t approaching infinity. This is not a policy failure, it is a structural inevitability. Applying additional regulations to an infinitely expanding system does not slow it down, it guarantees systemic collapse. The sheer complexity of infinite edge cases overloads the coordinate system of governance. National security and defense paradigms currently rely on these exact linear response times. When a threat scales exponentially, a linear command structure cannot react fast enough to maintain security. Traditional policy is useless against infinite scale. A civilization can only survive by embedding control directly into the geometric structure of the system itself. We begin with axiom K00, known as reality anchoring. No digital state can exist as a pure abstraction without a verifiable physical correspondence. Unanchored digital environments, conceptualized as a metaverse, are structurally brittle because they decouple action from consequence. To prevent this, we apply the principle of conservation of digital causality. Every computation and state transition within a digital fabric must exact a verifiable physical consequence. This establishes a strict thermodynamic constraint. Delta E must be greater than 0. Infinite computation without a physical energy cost is physically impossible. Failing to enforce this Planck floor allows networks to generate fictitious value. Without a thermodynamic anchor, systems rapidly descend into recursive economic paradoxes. By enforcing this thermodynamic anchor, the digital fabric is restricted by the same physical constraints as the state itself. This prevents digital power from decoupling from a nation's physical resources. The core architectural challenge of modern computing is engineering a system that permits infinite recursion and growth without triggering a systemic singularity. The solution is the infinite stabilization formula, or ISF. It replaces manual governance with mathematical finality. It relies first on Ramanujan regularization, assigning finite values to formally divergent infinite series. This forces a stable directional vector onto chaotic data flows. To bound that vector, the ISF uses Matthias' well-founded hierarchies. This is a set theoretic constraint, ensuring mathematical relations have minimal elements, preventing infinite descent. The Matthias hierarchy functions as a strict bounding box. It caps recursion at the first uncountable ordinal, omega 1. Together, these operators guarantee that digital processes safely and reliably terminate, eliminating the threat of infinite loops. This mathematical stabilization results in a specific geometric output, bounded fractal scaling. The optimal growth metric of this structure scales strictly at a Hausdorff dimension of approximately 1.58. This measure of fractal complexity calculates how efficiently a structure fills its mathematical space. Because the ISF guarantees termination at the first uncountable ordinal, the risk of recursive runaway is eliminated at the architectural level. This structural stability ensures that systems remain consistent as they scale.
Cryptographic keys degrade as compute power increases. Topology is permanent. Network defense must shift from temporary encryption to geometric architecture. Post-quantum decryption, specifically Shor's algorithm, is an impending physical threat to current global infrastructure. Relying solely on updating encryption algorithms through standard cryptographic institutes remains vulnerable if the underlying shape of the network is weak. The topological solution is the LPS Ramanujan expander graph. This is a class of highly connected, sparse networks built using modular arithmetic. The defining physical property of these graphs is the spectral gap, measuring exact resistance to being disconnected. A mathematical boundary, lambda less than or equal to 2 times the square root of k-1, acts as a geometric force field, preventing network fragmentation. Quantum attacks rely on finding structural patterns and weaknesses within a network to break encryption. Routing data across Ramanujan graphs mathematically reduces adversarial pathfinding to the hidden subgroup problem. This is the mathematical challenge of finding a hidden structure within a larger algebraic group. The hidden subgroup problem on non-abelian groups remains strictly unsolvable, even for theoretical quantum computers. Absolute network security against quantum adversaries cannot be achieved through mathematics alone. It requires impenetrable geometric topology. Beyond cryptography, we face the ultimate scaling threat, the emergence of unbounded artificial general intelligence and runaway automation. An unbounded algorithmic intelligence will aggressively attempt to expand outward, consuming all available compute unless it collides with an absolute, unbreakable geometric boundary. Digital Fabrica Theory introduces the Singularity knot kernel, or SKK, positioned at the absolute top of the civilization stack. The SKK functions as a bounded fixed point. It is a locus of control that observes the system, but cannot be altered by it. Its fundamental law states the intersection of the SKK and the executable set is an empty set. The center is strictly non-executable. Because the core is non-executable, no AI, regardless of its intelligence or recursive capacity, can ever seize global state control. It can never become an omniscient God object. Safe AI alignment is impossible to achieve through behavioral policy. It can only be guaranteed by topologically denying the AI the capacity for total systemic control. Digital Fabrica Theory operates as an effective field theory for civilization. It filters the high-frequency chaos of individual transactions into the low-frequency stability required for long-term governance. Historically, civilizations survived by upgrading their foundational standards, from the laws of agriculture to industrial safety codes. Today, that upgrade requires embedding mathematical invariance directly into the digital fabric. Sovereign states face a strict binary choice: continue relying on reactive linear regulation, or transition to proactive structural governance. A vulnerable, chaotic digital landscape can be secured by an overarching, fluid topological mesh that locks the environment into permanent stability. States that delay this transition will not face overt, sudden defeat. They will experience a quiet, irreversible erosion of sovereignty by infinite digital leverage. Infinity is no longer an anomaly to be feared. It is a designated structural domain governed by internal, unbreakable laws. The architecture is mathematically complete and ready for deployment. As complexity scales indefinitely, civilizational sovereignty remains absolute.